Hey everybody, and welcome back to Mr. Carroll's Classroom. Today we're going to talk about solving quadratic equations using the square root method. So let's go ahead and get started. Okay, so regardless of whether you're solving using the square root method or really anything, when you see something complicated in any equation in mathematics, we want to try to eliminate that complicated thing. And we pretty much follow the same steps to do this every single time. Let me bring this up. We first isolate that item, isolate that complicated thing, and then we use the inverse operation on both sides of the equation to eliminate it, wipe it out, right? That's what an inverse operation does, right? It's the opposite operation of the operation that you're talking about. So let's go ahead and see some examples, quick examples of this. We're not actually going to solve these, but just showing these examples. So I've got three different equations here. All of them have something nasty in there that we want to eliminate, something complicated. And so this first one, we have this quantity of x plus 2 squared. The second one, we have the square root of 3x plus 1. And the third one, we have this thing, you may have never actually seen this before, but this is called an exponential, where the variable is actually up in the exponent. So anyways, we have a 10 to the x. So the goal here is going to be to try to eliminate these using the inverse operation. But I can't just outright take the inverse operation of both sides right away, because you'll end up with something much more complicated than what you started with. What we need to do first is isolate each one of these items on one side. So let's go ahead and do it. Oh, and you can't see, so I'm going to kind of move over to the side here. But over here we have, you can see the x plus 2 squared is isolated. Here we've got this radical, the square root of 3x plus 1 is isolated. And we have this exponential isolated as well. Now we're ready to take the inverse operation of each side. And so obviously we're going to say, well, the inverse operation of the something squared is a square root. So we'll take the square root of both sides. The inverse operation of a square root is a square, right? So that's the direct opposite of the first equation. And you may have never seen this before, but if I have or if I have 10 to the x power, then the inverse operation is log base 10. So anyways, now after we do that, you will see that in green here, we have basically popped out what was stuck inside of that nasty operation. So in here, this x plus 2 was stuck inside of this squared. Well, you can see that when I took the square root of that, then the x plus 2 pops out. Over here, when I had the square root of 3x plus 1, the 3x plus 1 will pop out. And over here, I'm trying to get that x out of there. We're in 10 to the x. Well, if I take log base 10 of 10 to the x, then the x pops out. Okay, these are just a few examples of whenever you see something complicated, isolate it, and then apply the inverse operation, and you'll be ready to go. Okay? All right, let's continue on. Okay, so first of all, before another little note here for the square root method, this is directly related to the square root method. We have to remind ourselves, you should have seen this before, that whenever we take the square root of a squared variable, like x squared, if we take the square root of x squared, we must use plus or minus on one or the other side, but we typically do it on the other side. Okay, so let's go ahead and take a look and see what that means. So here's an example. If I have x squared is equal to 9, and let's actually just think about this right now. If really we could just do this in our head, right? 3 times 3 is 9, but also negative 3 times negative 3 is also 9. So that's where that plus or minus comes into play. But if I were to go ahead and solve this, x squared is equal to 9, I would take the square root of both sides because, well, first of all, this is isolated. The complicated thing is isolated. The x squared. But anyway, I would take the square root of both sides, but you have to make sure in green to take the plus or minus of the entire right-hand side. Technically, you could take the plus or minus of the left-hand side instead of the right-hand side, but we typically take it with the right-hand side because that's what we're trying to solve. Anyways, so the side with the actual numbers and everything. So anyways, when I take the square root of x squared, then the x just pops out, right? That's the goal. That's the square root is the inverse operation of something squared. So the x pops out. But we have to remember that we have plus or minus, and the square root of 9 in this case is 3, so we have plus or minus 3, which is the answer that we originally came up with when we just thought about this. X is equal to either positive 3 or it's equal to negative 3. All right, here's another slightly more difficult example. These are the types of examples we'll do in class. But anyways, if I have this equation, the quantity x minus 1 all squared is equal to x plus 2. If I wanted to eliminate this, it is already isolated, this complicated thing, so I'm going to take the square root of both sides. However, remember, you have to take plus or minus the entire right-hand side. Okay? Anyways, the x minus 1 will pop out, and then I have that is equal to x plus or minus the square root of x plus 2. Now, actually, there is something wrong here. This is not how I would go about solving this problem. This actually would lead you kind of to a dead end because you end up with something that is just as complicated. Take a look at this. I had an x minus 1 squared, and now I have the square root of x plus 2, and I didn't really get anywhere in this case. So I would actually have to backtrack and go to the original and then try a different route. Actually, in this case, you would go ahead and multiply this out, x minus 1 times x minus 1, right? And then you'd end up with some kind of quadratic, and then you could move the x and the 2 over to the other side so it equals 0, and then you could potentially factor or use the quadratic formula. So anyways, just because you isolate something and you do the inverse operation doesn't necessarily mean that you're headed in the right direction. Sometimes you have to back out and you have to try another approach. There you go. Okay, let's keep going. All right, another little side note here. And this has to do with why does the square root of x squared even equal x? Okay, you technically don't have to know this in order to solve these types of problems, but it is probably a good thing to know, and not only that, but it will really round out your understanding of what radicals are. A square root is technically what's called a radical. And so anyways, so why is that the case? I just want you to see a different form because this is not the only form of the square root. The square root actually has another type of notation. The square root, if you look at this little, we call it the index, this little blue number here, the square root has an index of 2. That's what makes it the square root. But technically speaking, it's the same thing as a quantity to the 1/2. So the square root is the same thing as something to the 1/2 power. It's literally the exact same thing. They're just two different types of notations. Okay, and for example, if I had the cubed root, which would have an index of 3 here, well, that's the same thing as taking whatever's underneath there to the 1/3 power. And fourth root would be to the 1/4 power, and so on and so forth. The 100th root would be to the 1/100th power. So yeah, it's really just a separate notation. And so to get back to our original question here, why is the square root of x squared equal to x? Well, in this case, you could rewrite this as the whatever's underneath the radical, which is x squared, to the 1/2. So that's x squared to the 1/2. And when I have something to the power of something else, you can multiply those powers. So 1/2 times 2 to get 2 over 2. That kind of looks like a 1 there, but that's x is, to the 2 over 2, which is really just x to the first power, which is just x. So that's why it works. Okay, the square root is really to the 1/2, and so if I have x squared to the 1/2, then I could just multiply 2 times 1/2 to get x, get back to x. Okay. Want to give you just a little bit more advanced examples here. Say, for example, I had the cubed root of x squared. What would that look like? Well, the cubed root is whatever is inside of there to the 1/3, like we just talked about. So that would be x squared to the 1/3. So that would be 2 times 1/3. So this would be x to the 2/3. So the cubed root of x squared is the same thing as x to the 2/3. And over here, I've got the 5th root of x to the 7th power. Well, that's the same thing as x to the 7th to the 1/5, which when we multiply that, that would be x to the 7/5. So just kind of giving you some different notation and try to kind of take out a little bit of the mystery of roots, not just square roots, but cube roots, you know, all types of roots, roots of any index. Okay. All right, let's get to the actual examples of using the square root method now that we've kind of hit all of our bases. Okay, so here's my first example here, and let's go ahead and apply all of our knowledge. Just grabbing a color here. Okay, so here we go. So here's my equation, and we can first identify the nasty bit here, which is this x minus 6 squared. So we need to isolate that. We need to get it all by itself, so that way we can then take the inverse operation, which is going to be a square root. But we need to prepare this. Okay, so I'm going to go ahead and I'm going to add 18 to the other side. So this is 3 times x minus 6 squared. And then 9 plus 18 is 27. And then I'm going to go ahead and divide both sides by 3 because I want to get that 3 out from in front of the x minus 6 squared. So I have x minus 6 squared is equal to 9. Okay, so now I'm ready. This thing is isolated. So what we're going to do is we're going to take the inverse operation of a squared, which is the square roots, which is, by the way, again, the same thing as taking it to the 1/2. Which is why these two will cancel. 1/2 times 2 is 2 over 2, 2 over 2, which is just 1. But anyways, you guys know it as the square root. So I'm going to take the square root of both sides. However, I need a little bit more room here. Let me just erase that. A little bit more room. Because whenever I take the square root of something, I have to make sure that I take the plus or minus of the other side. Okay, and it's not, I'm sorry, I kind of misspoke there. It's not whenever I take the square root of anything. It's whenever I take the square root of an x squared. Okay, or really an x to an even power, technically speaking. But you might be asking yourself, well, wait a second, there's no x squared in here. But actually, there is. If you multiply this out, x minus 6 all squared, that would be x minus 6 times x minus 6, which is equal to x squared minus 12x plus 36. And there is your x squared. So, so yes, technically there is an x squared inside of there. Okay, so let's go ahead and continue this. So we determine, yes, we definitely need that plus or minus. So here we go. So these are going to cancel each other out. The square root of something squared, well, the inside pops out to get x minus 6 is equal to plus or minus the square root of 9, which is 3. Square root of 9 is 3, so plus or minus 3. Okay, now I'm going to go ahead and add 6 to the other side. So I would say x is equal to 6 plus or minus 3. Now you could go ahead and list this as your solution, which is normally what we would do. Or you could separate this out to the different cases. That would be x is equal to 6 plus 3, which is 9. Or x is equal to 6 minus 3, which is 3. So technically this could be your answer as well. You could write it as a set with little curly braces, however you want to do it. But all of these are valid answers. But I would technically, I would prefer just to, oh, I'm sorry. I'm not going to prefer to leave it like this. If I had like an x value in there or something like that, I would leave it like that. But we are going to actually take each case. So 6 minus 3, let's go ahead and put our little squigglies here to make it official, is going to be 3. And then 6 plus 3 is equal to 9. Okay, there we go. There's a nice official answer in set notation. Okay. All right, let's do another one. Okay, so same type of problem here. Let's see if it gets a little bit more difficult. This one should. So the first thing I'm going to do is I'm going to add 29 because I want to isolate this complicated piece. And by the way, if you ever have more than one complicated piece, if you have 2 complicated pieces, you isolate one of them first, undo that one, and then hopefully you can isolate the second one after that and then undo it. But those can be tough problems. Maybe we'll see those later on. But anyway, so I'm going to add 29 to both sides. So I am stuck with 2 times 5x plus 1 squared is equal to 58. 29 plus 29 is 58. Then I'm going to go ahead and divide by 2, both sides by 2, to cancel out that 2. And so I am left with 5x plus 1 squared is equal to 58 divided by 2 is 29, it looks like. Yep. Of course, because we just added 29 divided by 2, another 29. Okay. Let's go ahead and we got this nasty part isolated. So let's go ahead and undo it. So I'm going to take the square root of both sides, but don't forget that plus or minus out front of the square root of 29. And so the inside is going to pop out. So I have 5x plus 1 is equal to plus or minus, 29. Square root of 29. Can I simplify that at all? And I don't think I can. So yeah, so let's go ahead and we'll just leave it as the square root of 29. There we go. Cannot be simplified. All right, that doesn't mean I'm done. I can go ahead and isolate x now, right? Because that's what we're solving for. So I'm going to subtract 1 from both sides. So that's going to be 5x is equal to plus or minus 29. Actually, let's do, let's put the 1 first, usually. So it's going to be negative 1 plus or minus the square root of 29. Then I'm going to go ahead and divide both sides by 5. All right, so our final answer is going to be x is equal to negative 1 plus or minus the square root of 29, just because usually our radicals, if we have them in our answer, usually come after a whole number, so after. But anyway, all divided by 5. So there you go. You could leave your answer like that. Sometimes you might see the answer separated out, meaning this 5 here is the same thing. If I'm dividing all this by 5, you can divide each one of these by 5. So it would look like this. You might see your answer look like this as well. X is equal to negative 1/5. All right, putting that 5 with the 1, plus or minus square root of 29 over 5. And that is a valid answer as well. We'll call it an alternate answer. Okay? Either one is totally appropriate. Okay, let's do one more problem here. Alrighty, so same type of issue here. I have a complicated piece. I need to isolate it, so I'm going to go ahead and add 5 to both sides. So I'm left with 2 times x minus 2 all squared. And let's see here. If I add 5, that's going to be negative 18. Now I'm going to divide by 2. Divide both sides by 2. Getting the left side is equal to negative 9. Now the complicated piece is isolated. So let's go ahead and we're going to take the square root of both sides, but be careful with that plus or minus out front. It's really hard for me to squeeze it in there. Sorry about that. But either way, our inside is going to pop out, giving us x minus 2 is equal to plus or minus, the square root of negative 9. Okay, so we just learned about imaginary numbers, and so we can actually take the square root of a negative number. And let me just show you the breakdown of this without skipping any steps up here, and then I will pop it down here. So if I have the square root of negative 9, that's equivalent to the square root of 9 times the square root of negative 1. We can actually separate these out according to our radical rules. So that's totally fine. And now we have, this is equal to, well, the square root of 9 is equal to 3. And what is the square root of negative 1? Well, that is our imaginary unit I. So the square root of negative 9 is 3i. All right, so let's go ahead and write that in here. So that means x minus 2 is equal to plus or minus 3i. And let's go ahead and isolate our x to solve for x. So that means x is equal to 2. And just like the radical, if we have an imaginary number, we typically put it second. We list it second. So I'm going to say 2 plus or minus 3i. And there we go. We have our final answer. Answers, I should say, 2 answers. 2 plus 3i and 2 minus 3i. Okay, so there you guys go. There is the square root method, and essentially it involves just isolating the complicated piece, and then go ahead and apply the inverse and just follow suit with your algebra. Hopefully this helped you guys out, and I'll see you in the next episode. Have a good one. Bye now.